Okay, so let's make a start. The last day we left off at um, HCF and LCM. Anybody can remember what those stand for? What is this HCF?
Highest common factor and lowest common multiple.
Great, great. Right? I'm hearing this sound a bit muffled. Could somebody else speak? Or let me see if it's the same thing.
It's the same thing over here for me too.
Oh, well, you sound clearer. That person who spoke just now, you sound clearer. The
Good
first
afternoon,
person
sir.
in the yeah, sound clearer. Okay, all right, good. Yeah. So indeed, yeah, that's correct. Highest common factor, lowest common multiple. I've seen textbooks use other terms, right? Like instead of this, they say GCD, right? Greatest common divisor, right? And I think the whole idea is that they mean the same thing, right? We say lowest, sometimes say least common multiple, right? Sometimes you hear that least common multiple. They mean the same thing, right? Yeah, you all know synonyms can be used to describe these things. Why are they important, right? Let's talk about HCF. Why HCF is important? Um, in algebra, and you'll notice the course is largely algebra, right? Um, when it comes to factorizing, right? Factorizing algebraic expression, this matter of highest common factor is going to come into play, right? So it's good that we are introduced to it now. We're not going to talk about highest common factor of algebraic expressions just yet. We're not going to deal with that yet, right? But just the idea of highest common factor of a set of numbers. We'll talk about that. And when it comes to fractions, and we'll deal with algebraic fractions as well, right? And the need to find LCM, right? To add and subtract fractions is going to be important. I'm going to give you an example with algebra as we go down into the discussion, right? So let's start with HCF. HCF. And let's say you have a set of numbers, Well, if you have one number, you don't have so much problems, right? But if you have a set of numbers, and let's use an example, an example. Example of HCF, right? So we're looking for, okay, find the HCF of, and let's take some numbers. Let's say 15, let's go with 20, maybe 25. Right? So let's go with, I think let's go with some bigger numbers, maybe. Let's go with some bigger numbers. Let's go with 45. Let's go with 60. And let's go with 75 here. Right? LCM, you play around with smaller numbers. But let's say, okay, use some bigger numbers, right? Good. Well, one of the first things, by the way, they have several methods of finding HCF and LCM and so, right? I'm only going to talk about one. And the one I'm going to talk about is using what we call prime number factorization, right? In other words, I'm going to write each of these numbers as a product of their primes, right? And every number, I think I said this the last class, and every number can be written as a product of their prime factor, right? So like the number 45, let's see if we can break up 45. 45, what will we get? Let's see if we can write it as, I mean, by now, not everybody can watch it and write it right away. So let's see, we can go with 5. What is 45? 5 nines, but then 9 can be broken up into 2 parts, right? So it's equal to 5 multiplied by 3 multiplied by 3, right? Some people might do it the other way. They'll say 9 5s, right? So let me do it that way. Let me do it that way. Let me write it that way. So yeah. So let's go with 9 multiplied by 5. But 9 isn't prime, right? Well, we're getting there. We're getting there. 9 is 3 by 3. These are primes by 5. So we got 45 broken down, right, into its prime factors multiplying to give 45, right? So we are right. We just wrote 45 as a product of its prime factors. So let's go with 60. 60, how will you say 60 is what? 6 by 10 is 60, or we can break up 6 to be 2 by 3, and then 10 is 2 by 5, right? Yeah. If you want to write that back nicely, you can put 2 by 2. If you write it back, we can write it back. 2 by 2. Two by 2 by 3 by 5. Would that be right? 4 by 3, 12 by, yeah, okay, that's correct. Let's go with 75, right? So what would I say about 75? What would that be? 3 by 25 will give us 75, which can be written as 3 by 5 by 5, right? Good. So what we have basically done here now is we wrote all 3 numbers in terms of its prime factors, right? What we call prime factorization. There is a theorem in mathematics that says every number can be written as a product of its prime factors, right? So you don't have to worry that, man, some wouldn't work and some would work. They all will work. So what we got to look for now is the factors that are common to all of them. So help me now. Tell me what factors are common here now.
5, sir.
Which one?
5.
5, okay. So we're seeing a 5, all right. Let's do that.
3 and 5, sir. Good afternoon, everybody.
All right. Somebody says 5 4. Sorry, there's a 5 here, there's a 5 there, and there's a 5 there, right? So let's have our 5 there. What else is common in all 3 of
3,
these?
sir.
3. Okay, there's a 3 here, there's a 3 there, and there's a 3 there, right? So we got 3 by 5, right? So that's common. Anything else? We got a 3 here, but no more 3s here. No more here. There's a 5 here, no more 5s anywhere. There are 2s here, but no 2s here, no 2s here, right? So what we found out then is the HCF of these 3 numbers is equal to 3 multiplied by 5, which is 15, right? So that's a simple approach to finding HCF, right? When you have to deal with a set of numbers, right? I did send you some notes. I sent you some notes. I don't know if you noticed it, on number theory. And the last little subtopic got some more examples on finding HCF. And this is one of the methods that they have there, right? So you can always look at some more examples. Please, you have to do a little bit of reading too on your own, right? Don't depend that I must tell you everything, right? You're growing up, you're developing. I mean, I know most of you might be adults in the class. And adult people, they take responsibility for their learning. They need to be lifelong learners, right? So as a matter of fact, you could, if you want 100 examples on finding the HCF of a set of numbers, right? If you're a sensible person, you just go on YouTube and type in HCF. You just type in HCF and you will see some wonderful videos, right? You'll see a lot of videos on finding HCF, right? I tell my students, you all hardly need me, right? What you need me for is to give you the test and mark the test and give you a grade. Everything is out there, right? So I gave you some notes. As I said, you could always YouTube a few more examples and so, right? Before I move away, I just want to show you a type of problem that you can see when it comes to HCF, and you'll know that's an HCF problem, right? So let's say the people say, watch, they have a room of, all right, let's go with the number just now we had. The room is, what was it? 75 by 60. Let's just say. And you have to tile this room. You have to tile this room. Right? And let's say the tile, and all right, I know nowadays tiles come in rectangular form. They're not all square. But let's just say they want square tile. What is the largest tile that you can use, right? In this room here, so you don't have to cut any. Right? And the assumption here is that, well, you're hardly going to put any spaces between them. Let's assume, and again, these real life problems, they don't consider all those finer things that, between each tile, there's a little space and so. So let's just assume that, okay, man, we're not going to let any space be between the tiles, right? So basically, this is an HCF problem. What you need to find is, okay, HCF of 60 and 75, which is, again, I think it's 15, right? Same 15. Is it? I think it'll still be 15. Let me see. Let me go back here. 75.
Yes, sir.
Yes, it'll be the same 3 and
Same 50.
same 15, right? So in other words, a tile that is 15 inches, if there exists such a tile. And that's a funny thing, or I should say, the thing about real life problems, right? Very often when we try to have a real life problem in mathematics, some of it might not be practical. We have to oversimplify it. Like I told you, this is assuming that there's no space between the tile. The tile fit, 15 by 15, 15 by 15, 15 by 15. There's no space. There's no space, right? So a 15 by 15, 15 by 15 tile, right? A square tile, 15 by 15 will actually, you can draw it. You can draw it and see, right? You will have 4 15s there. Oh gosh, I already get it small, right? 4 15s there, and how many 15s this way? 75 divided by 15 is how much?
5, sir.
5, yes. I think I have too many tiles here. You'll have 5 across, and 4 this way, right? And in that way, you don't have to do any cutting. But remember the assumptions, right? That you can't have any space between the tiles, right? They're tightly packed, right? As well as, I am not sure there's a tile this size in the store, right? I'm not sure there's a 15 by 15 tile. But let us just say that, man, you have a store where any size tile you can get, right? Any size tile. So this is a classic example of an HCF problem, right? Because when you see the problem, as a matter of fact, if you were to read the notes I gave you, you'll see some questions like that, right? And you have to know that, you know what? Hey, this is an HCF problem. Right? This is an HCF problem. So that's that. As well as I told you that HCF will become important when you want to factorize. Right? Let's say we want to factorize. I'm just awakening your appetite, right? Factorize. Let's say you're given an expression, right? Let me just go with x cubed plus, let's go with 3x squared plus, let me go with 6 here, 6x squared, x cubed plus 3x squared plus, let me go with 9x, let's go with something like that. You have to factorize something like this, right? So you see, you have to find the HCF of this 6, 3, and 9, which you easily recognize to be 3, right? And then you have to find the HCF of something like x cubed, x squared, and x, right? And you can see that it's x. So your highest common factor is going to be 3x, right? And then you're going to divide this now by 3x, and you're going to get 2x squared. You're going to divide this by 3x, you get x. And you divide this by 3x, and you get 3, right? And then maybe there's a way to further factorize that. But I just wanted to show you how HCF comes into play, right? When it comes to factorization of algebraic expressions. We're coming to that later in the course. I just want to show you why HCF is such an important thing, right? It plays a big role in algebra. Good. So we talked a little there about HCF, right? Let's go to a little bit on LCM. LCM.
Sure.
Yeah.
Before you move on, sorry
Yeah.
for joining.
Yeah.
How
No, it's
do
all
you
right.
find the HCF for a number?
Well, the highest common factor of any number is the number itself. So you very talk about highest common factor. All right, let me go back that term. That's why we say common factor. Let's say a number, 100. The highest common, the highest factor of 100 is 100, right? But when we speak of common factor, we're talking about a set of numbers, right? So let's say 100, 250, 300, When you talk about common fact, highest common factor, you have to have a set of numbers. You think you get me, or did that answer your question? Or any number in the whole wide world, it's the highest factor of the number is the number itself. Because I guess we got to go back to the definition of a factor. A factor of a number is a number that can divide the number without a remainder. Yeah. So
Got you, sir.
the highest factor of 100 is 100. But when we're talking here about HCF, we have to have a set of numbers. You can have 2 of them, you can have 3, you can have 5, you can have 10, right? You have to have a set of numbers. So you're looking for the common factor, right? So maybe let's do this one for a second example. It's a good question. It's not a bad question.
Thanks, sir.
All right, let's get another one. 100. 100, all right. That's what, 10 by 10. And if you break that up further, you get 2 by 2 by 5 by 5, right? This is 4 by 25 will give you 100, all right. Let's go to 250. 250 is like what? 10 by 25, right? Which is 2 by 5 by 5 by 5, right? By 5. Now we got 300, which is what? 10 by 30. You go 10 by. How you go with that one? 10 by 30. You break this up, you get 2 by 5 by 30 will be what? um, 5 by 6. And this 6 can be further broken up into, okay, 2 by 2 by 3 by 5 by 5, right? It takes some doing, right? And I'm deliberately not watching the thing and give you the answer right away. So when I break this up, I get this, right? 2 by 5, that's 10. 5 by 6, 30. So this 6, 2 by 3 is 6, right? And then the 2 5s, good. So I'm going to erase this, right? And can I, oh gosh, take this, okay. Put it there. All right, good. So now we can look for common factors, right? So what do we see common? I'm seeing a 2 there, all right, a 2 there, there's a 2 there, and there's a 2 there. All right, so we got 2. 2 is common. There's a 2 here, but there's no 2 there, and there's a 2 there. So 2 isn't, there's no more 2s that is common, right? Let me go with 5. So there's a 5 here, there's a 5 here, and there's a 5 here. So, okay, 5 is common all over. And then there's another 5, and then there's another 5, and then there's another 5. So these are the common factors. So we multiply them, and you will get 2 5s, 10, 10 5s, 50. So 50, right? 50 is the highest common factor of these 3 numbers, right? Of these 3 numbers, right? So my good friend asked a question and it prompted some explanation that brought out something, and then you get an extra example, right? As I said, here, if you know you're doing this course, my advice to you is this. We have 2 hours of class, yes, but don't count on that alone, right? If you were absent from the class, well, you can watch my video. You see this video already. As I said, if you're in the class, have a notebook, right? That somebody said the example here, they ask a question. So I like the little participation I'm getting, right? That's very nice. And one of the things you want to do is, okay, spend a little time during the week. Maybe you take out an hour and you say, you know what? You don't have to be an hour. Maybe you could take a 50 minutes and say, you know what? The man talk about HCF and LCM. And you can criticize my writing and say, man, he writes scrally for the board and so. Like on YouTube, there must get some nice videos with animation and so. And you go on YouTube and you type in HCF, how to find HCF, something of the sort. And they have all manner of videos there that will show you. When you finish, you might come back and say, sir, I learned 3 other methods for finding HCF. You want to show you? You will know more than me when you finish, right? So nothing wrong with that, right? And you can go learn extra stuff. That's okay, right? That's okay, right? You can even ask an AI. You go into any AI. You go into them and you just say, give me 5 examples of finding HCF of a set of numbers. And the AI would spit out 5 examples for you. Some of them would read the explanation to you. I got an AI, I have to find it back. The other day, I looked at I was doing something. I was trying to prove, I was showing a set of students a proof. It's one of these trigonometry courses. So I wanted a proof that is very simple, not the one that I had in the textbook. And I went and I asked this AI, forgot what the AI name. It gave me the proof. And then this is the question the AI asked me now. Do you want me to make a video of this this proof? I said, what? Anyway, I clicked. I said, yes. And you wouldn't believe me. The AI made a video for me. I couldn't download the video, but it made a video and you play it right there. Click it and you play it. I said, oh, what is this now? Right? I would think the AI, if I ask it, explain the salsa dance or something, right? Or some kind of dance, right? And if it asks me make a video of it, I'll say yes. And let me see if we'll make a video of somebody dancing. So AI is doing great things, right? And make use of it. Make use of it, right? You don't want it to get in the way of you developing your thinking ability, your cognitive processes, because that's what this course is about. But it is not saying you can't use AI at all to help you learn stuff, right? It's a beautiful tutor, right? That you can make use of. Good. So let's switch over to let's talk a little about LCM now. LCM, and I hardly think I have to explain why this is so important, right? You all have dealt with fractions in whatever elementary school, primary school, secondary school, right? And even in that earlier course, you probably did some fractions. So you know the use of LCM, right? And maybe that's where we'd have to, okay, let's say you want to find the LCM. And again, I'm just going to show you one method, right? There are others out there. You want to find the LCM of, give me some numbers. Let's say 6, 8, and maybe 12. Let's go with that, right? Again, one of the keys to doing it is to write each of these as a product of their prime factors. So 6 is written as what? 2 by 3, right? 8 is going to be 2 by 2 by 2. And 12 is going to be, what is it? 2 by 2 by 3, right? Let me take this up a little. Yeah. Good. So what we want to do here is we want to represent all the factors here, right? So, okay. There's a 2 here, right? There's a 2 there, there's a 2. Okay, so we go with 2, right? There's a 2 here, there's a 2 here, but no 2 there. So you'll have to go with another 2, right? Another 2. Similarly, you'll have to go with this other 2 because even though there's no more 2 here and no more 2 here, we have to account for this 2, right? So we go with another 2. And then there's a 3 here. There isn't a 3 here, but there's a 3 there. So you include the 3. So the whole idea is you make sure you capture all the factors. But if a factor is common to all 3, you don't repeat it 3 times. Let me see if you get that, right? So look here. They have a 2 here, they have a 2 here, they have a 2 here. Doesn't mean that we're going to have 2 3 times. We're not going to have 2 by 2 by 2 by 2. Because the 2 is common for all 3 of them, you include the 2 once, right? Then there's another 2 here, there's another 2 here, but there's no 2 here. But we have to represent this 2 now, right? We're not going to put 2 by 2. We're going to just use 2, right? And that's what we got here. Similarly here, you have another 2 here. There's no 2, there's no 2. But we have to represent this 2 in the calculation here. There's a 3 here, there's no 3 here, but there's a 3 here. But because we have a 3, we have to have it in the multiplication. Right? And when we multiply, I think the answer is what? What's that? 24? 24. Right? So that's the key to the whole thing. You include all the factors, but if a factor repeats itself, right? In all 3 of them, don't repeat it 3 times. You don't repeat factors, right? You get what I'm saying? Watch. There's 2 here, there's 2 here, there's 2 here. That doesn't mean you're going to put 2 by 2 by 2. No. You ensure you have just 1 2, that's this one here, to represent these 3, right? Then there's another 2 here. It's here, but not here. So we're not going to use 2 by 2. We're going to use just 2, right? To represent the common factor 2. Then there's another 2 here. There's none here, there's none there. So we put it back again, right? And then there's a 3 here, there's a 3 here, but no 3 here. So we're not going to put 3 2 times. We're going to put 3 1 time, right? So each factor that is common, right? It does not have to be common, but it's in the factorization. You have to represent it once, right? Just ensure that each factor, right, that is in the prime factorization is represented, right, once. So when you look at these 3 2's, you represent them once. You got these 2's, this one and this one, you represent it once. You got this 2, you got to represent it once. You got 3 2 times, but you are representing it once. And you have exhausted all of them there. So your answer is 24, right? Just make sure you don't duplicate, okay? You have 2 by 2 by, don't put 2 by 2 by 2, no. These 3 will be represented once by this 2 here, right? Now, apart from, okay, fractions, there are some problems that LCM, okay, somebody is asking, yeah. Shivani, yeah?
So basically, sir, each two is representing one of the two in each column. Is that correct?
Yeah, yes. Like of this 3, you're not using 3 of them, just 1, right? Of these 2's here, these here, just do represent here by 1 2, not 2 times.
Okay.
Right? There's a 2 here,
Okay.
there isn't any other 2 there, so you have to include it. There's a 3 here and 3 here, but no 3 here, so you have to represent it once, right?
Okay.
Let's do another one, maybe. Let's do another one. So let's.
In the other explanation, can you use like a different color to just show? Because I'm seeing someone in the chat too, one is not getting it as
Okay,
well.
okay. Let's go with another one. Find
Thank you.
LCM or let's go with 3 numbers. I'll go with 9, 21. Let's go with. Give me another number there. While 6, maybe 6. Will we find that? Let's see. Yeah, horrible no R. 9 is equals to 3 by 3. Okay. 21 is going to be what? 3 by 7. And 6 is going to be 2 by 3. Good. Good. All right. I should have put it 3B. All right. So we're looking for all the factors now that are in these 3 prime factorizations, right? You still have your hand up, Shivani?
Yes, sir. Sorry about that. Let me lower it.
Okay, good. So we got 9 is 3 by 3. We got 21 is 3 by 7. And we got 6 to be 2 by 3, right? Good. So we're looking for factors that we want to represent all the factors, right? But remember, we are not duplicating a common factor. So we want to include all the factors, but we are not duplicating common factors, right? So let's see what I'm saying. We got a 3 here, we got a 3 here, we got a 3 here. But we're not duplicating them. We're just putting 3 for these here, right? So let me use another column, maybe red. So for these 3, there are 3 3's that is common to all, but we're not using 3 by 3 by 3. We're using just 3, right? Good. But we have to represent the other factors. There's a 3 here. Let me use another color maybe. Green, yeah. This 3 here. There are no other 3's, but we got to represent it because it happens to be a factor of 9, right? So we got a 3 there. We got a 7 here. 7 is nowhere else. We got to put a 7. And then we have a 2 here. It's nowhere else, but we got to put a 2. And let's multiply these. Somebody help me. That's a big number. I suspect we'll have a horrible number. Somebody's doing it for us. 21 by 3 gonna be 63. 63 by 2 is what? 63 by 2 would be
126.
126. Yeah, right? A horrible number, but yeah, just to illustrate the point. Right? Remember that. We got a tree here, a tree here, and a tree here, but we're not writing 3 by 3 by 3 when we're finding LCM. We are going to use only 3 one time. We're going to use 3 only one time to represent this common factor. Right? This 3 comes from, well, the other 3 that is there. Right? It's not common to the other 2, but we have to include it. The 7 is not in the other 2, but we represent it here. The 2 is not common to all 3 factorization, but we include it. Right? Just remember, you include all the factors, but when you have a replicating or a repeating factor, you don't repeat it here. Like the 3, right? 3 here, 3 here, 3 here. We didn't repeat it, we use it once. Think you get that?
Yes, sir.
Good. I'm seeing another hand up. Tiffany?
Yes,
Tiffany?
sir. Good
Yeah.
afternoon.
Yeah.
Why is it that we are multiplying each of the factors?
Well, the simple reason is that we're looking for what you call the lowest common multiple of these numbers, right? So basically what we're doing, we're taking the common factors of each of these and we're multiplying them. We're not necessarily taking the number and multiply them wholesale, but we're looking for their factors, right? And once we represent all the factors in the number and we get the common ones, right? When we multiply them, we will get the LCM. It's just an arithmetic procedure that works based on the fact that you can write any number as a product of their prime factors.
Okay, so I get that. So the process is how you picking out the multiples, right? Then we multiply it. So in other words, when we multiply it, 126 gonna be the LCM of 9, 21, and 6.
Yes.
Okay, thank you.
Yeah, remember the process. Listen to the procedure back one more time. Take each number, write it as a product of their prime factors, right? Take all 3 of them, we did that. And what you're doing next now, you want to include LCM will be a product of all their factors, but you're not going to duplicate common factors. You see? So there's a 3 there, there's a 3 there, there's a 3 there. We're not duplicating these 3 times. We're only using it 1 time. The others, we're only using 1 time, right? That's this 3, this 7, and this 2, right? So we include all the factors. The only thing about it is that if you have a common factor, like the 3 here being common all 3 times, don't use it 3 times, use it 1 time. Right? Maybe we'll do a problem or 2 more and to help clarify it. Let me go to a kind of problem. I remember when I was a kid, I shouldn't say that. I think it happened to me when I just started to teach. I was a young boy, little kid, you know. And I remember seeing in the textbook a question like this. What is the least amount of, let's say, mangoes that could be shared was it equally, they say, could be shared equally. Trying to remember if that word is inside. By, let's say, 3, 6, or 9 persons. I want to know what kind of problem is this. Let me just borrow. Just give me a second. I'm not sure about the wording here. Let me borrow it from the. Give me 1 second. I'll stop the sharing. Right. Let me borrow it from the 1 second. Uh, all right. I'll borrow this one just to show you. Make it a little bigger. One second. Coming back there. Don't worry. Okay. Yeah, I borrowed this one from the textbook. So it asks, what is the smallest number of sweets? Well, that's what I was saying, right? That can be shared exactly among 5, 10, or 15 students. And I remember when I was, as I said, a young boy, I wonder what kind of problem is this? You know? And to be honest, I'll tell you that I didn't know the answer. So what I did, I checked the answer the back. So they had this textbook and they had this question. Not this exact one, something similar, right? So I decided, I said, man, let's see where's the answer. Like I can't pick up the answer. And when I saw the answer, basically it was the LCM of 5, 10, and 15. What would it be? 30? 30. Right? And when I saw 30, I looked at the numbers 5, 10, and 15. And I wonder, well, what's the connection with 5, 10, and 15? And 30 happens to be the LCM of 5, 10, and 15, right? And what they're telling you here is that, all right, if you have 5 students, they will all get 6 sweets each, right? If you have 10 students, right, they'll all have how much? 3 sweets each. And if you have 15 students, they will all have 2 sweets each. So this is the least number of sweets you can have. That if you have 5 students in a class, well, they'll all have equal. It's like you don't know how many students going to turn up, right? You have a hunch that, man, you can either have 5 students in class, you can have 10 in the class, or 15. I know it's, again, an oversimplified. You want to know, sir, how you know that 5, 10, or 15 students will come, right? You understand? Remember, these real-life problems, sometimes they're oversimplified. They don't take a lot of things into consideration. But basically, what I'm trying to show you is that this is a LCM type of problem, right? And I'm just telling you that when I was a kid starting to teach, I was puzzled by it, right? I like to tell these stories because, people feel that, well, this guy is this maths teacher and he knows a lot. I'll tell you, a lot of things I learned in a very hard way, right? I'll tell you a story just now. I think I told the class last night how I got to learn that thing. Very embarrassing and humiliating, but it was a lesson I can never forget, right? All right, yeah. Another usefulness of LCM, as I said, as we proceed in the course, we're going to get into algebraic fractions. Algebraic fractions. Not today, but I'm just telling you, we'll have to deal with this, right? And if you have to add algebraic fractions, like, maybe, okay, 1/3 x plus A quarter. Let me go with R. Let me just give you an equation just to illustrate something. 1/3 x plus, let's say, 5/8 is equals to a quarter x minus quarter x minus let's go with 3/8. If you have to solve something like this, one of the suggestions, and this is one of the methods, they tell you to multiply everything by the LCM of 3, 8, and 4, right? So you look for the LCM of 3, 8, and 4. I wonder what will that be? 24? 24, right? You multiply everything by 24, and it will get rid of all these fractions, because 24 by 1/3 is going to be 8. You get 8x. 24 by 5/8 is going to give you what, 15? Equal a quarter by 24, you get 6x, minus 3/8 by 24 will give you 9, right? So now you got rid of all the fractions. But how did you do it? You have to find the LCM of 3, 8, and 4, right? Which happens to be 24. So you're seeing the usefulness of LCM, right? I'll tell you what, though. The LCM that you will have to find in the HCF and so are going to be very, very simple. You don't even have to know the methods that we talked about earlier. Because when you're dealing with equations and so, you wouldn't deal with all these big, big numbers, right? Most of the time, equations and so will have very small numbers inside, right? So don't fight up yourself and say, man, this LCM, HCF thing is going to puzzle me and I'll never be able to handle equations and these other things. No, right? As I said, though, if you want to see all the fancy methods of finding LCM, HCF of numbers, you just go on YouTube and you watch a few videos and you'll become a master by yourself. I'm just showing you where all of it is going to lead, you know? Good. So now that we talked about, what is it, LCM, HCF, and so, our next, let me stop sharing for a moment. Stop sharing, okay. Go back to our outline. Here's our outline. 1 second. Good. So we are somewhere here. And as I said before, I sent you a chapter from it's basically CXC textbook that covers all these sets of numbers, right? Please read through them, right? There are little definitions. What is a prime number? What is a composite number? What is a square number? You know, it tells you all of them, right? And do some reading on them, right? Good. So we're over here now. We're over here where we're gonna talk a little bit about a little bit of algebra business here, right? Oh,
Hi, sir. Good night.
yeah.
Sorry for this stuff.
Alright.
How would the exam be coming? Is it multiple choice or is it thing we have to do some? How will it be coming?
I haven't decided that yet. I'll let you know when we're closer to that, because I have all kinds of ideas in my head sometimes.
Excuse me, sir.
Thank you.
Yeah. Somebody else had a question?
Yeah, when it comes to exam, will we doing it face to face or over Zoom?
No, it's over Zoom. I'll be watching you
Oh,
doing the exam.
all
Most
right, good.
most of it does be multiple choice. I know in the past, IDC insists that, especially final exam, they want us to give you all some essay questions to write, right? And usually what I would do is I'll have you write your solution on a piece of paper. You take a picture of it and you upload it, right? So that can be done. But you do minimal writing. But you shouldn't shun away from writing, right? I think what is happening with this online business is that, well, don't talk the cheating that is going on and so, right? And we're trying all kinds of things to curb that. But one of the things that we're trying to do is, get students to you got to still learn to write mathematics, right? Just don't circle an answer and you're not sure how you got it and all of that, right? So you might very well have something to write, right? Especially in the final exam. The other tests maybe, well, and mind you, my multiple choice are very queer multiple choice, right? I got some questions where you might have to do some check boxes. And if you get one wrong, you get all wrong, right? That's how the thing will mark it. You have to get everything right. Right? And I have some strange questions that when you read them, you really toss up your brain and it wouldn't be a very simple multiple choice test, right? Yeah, let me not scare you. Stop thinking about tests, man. You will learn the content and we can get to tests later on, right? Don't worry about the exams. I think we have this exam culture, like, that students forget that mathematics, and this course in particular, is about developing your cognitive processes. I keep saying that over and over, right? And you don't worry about, well, man, whether the thing is multiple choice or essay, whatever it is, you have to develop to the point where you can answer anything. You throw anything at me, sir, I'm ready. That's the attitude I want, right? Oh God, the man will bring the man. I got write out solution, but you can't get that in your head, right? You have to prepare for anything, right? The whole idea is you have to grow mentally, right? Some of you in this class might go on to be managers. You might go on to who knows, study law, right? When you go in that courtroom, logic is important. I was telling a student, a group of students, they're math teachers, right? And when they're answering problems, they start answering problems just like that. Start the solution. I say, stop. I say, you always watch a show named Law and Order. None of them don't watch Law and Order. I don't know what kind of students you got nowadays. All they're watching is stupid vampire movie and vampire this and, somebody chopping up somebody and Walking Dead and all this, the shows that could teach you nothing. That's what people watch, right? I know I'm imposing my views on you here, but I don't see anybody watch a show like Walking Dead, something about Walking Dead. Anybody? Is there an honest person in this class?
No, sir, I don't do those things.
I want to know I just want to know. I wish somebody in the class does watch it. I want to know, what do you learn from something like that? Anyway, if anybody's brave enough, must tell me what you would learn from what is it? Something about the Walking Dead. I see it coming up on the TV area often. Yeah, by the way. So I was telling the students, I said, listen to me. When you see, okay, you're watching this movie, this show, Law and Order, when they're doing a case, one of the first things they do is what you call opening arguments. And what do you do in the opening arguments? You don't start presenting proof, no. You are going to tell the jury and the rest of the court, I believe that this man is guilty, and in the days to come, I am going to prove, right, with this, and this, and this, and this, DNA evidence, fingerprinting, eyewitness testimony, character testimony. I'm going to show motive. You give me an overview of what you are going to tell us in the weeks to come. Then the opposition, the defendant, now the defendant law is going to stand up and, they're going to now say, well, all right, I'm going to the people, right, or the prosecutor is saying this. But in the days to come, when he present those, I am going to show you. And he's going to say, well, what he's going to present to the contrary. So that's what you do at the beginning. Don't start working the problem. Tell me your strategy. What are you going to do? So we don't come tomorrow and what is man talking about? No surprise. You must tell people what you're going to do and give them an overview. Then you're going to say, no, just like the man says, all right, today we are presenting character witnesses, to talk about the person who, more than to say, well, this man is a fighting man in the village. He chopped 2 people, he beat up his wife. And so on. Next day, you say, all right, good, we're looking at fingerprint evidence. The cutlass had his fingerprint on it. We got a receipt to show he buy this cutlass. Them kind of thing. And then the next day, you say, all right, good. We're going to look at some eyewitness testimony, people who see the fight, right? And so, and you understand, you present it step by step, and then you tie it all together, you call closing arguments. That's how you show, when you're doing a presentation of mathematics, that's how you do it the exact way, right? The teachers are watching me like, what is wrong with this guy? I said, that's logic. That. If you go in a courtroom and you don't understand logic, you ain't gonna win no case. You're gonna be one of those, the lawyers who the government does hire, the leftover lawyers, like the government does hire them to represent people who can't afford a lawyer. Right? You want to be a top-notch lawyer, you got to understand logic, right? You got to know how to argue, and mathematics help you to argue. If you can't write out your thoughts in logical order, you can argue nothing. Let's say you're going to be a manager and you got to make a presentation. You want to do a campaign where you want to sell this particular thing. You got to go in front of the whole board now, and you're going to say, look, I want us to do this product, make this product, and sell it. And so many people say, all right, good, let's see. And you can present market research to show the need for the thing. You haven't worked out, the design of the thing, who will manufacture the thing, the costing of the thing, the marketing of the thing. You don't have none of that, you're in trouble. Logic is important, even, you become a manager, right? You understand? No matter where you are, logic is very important, right? You have to be able to think logically, and that's what this course is largely about, right? Anyway, yes, Howard.
Yes, sir. One more question concerning with this essay thing for the maths, right? Is it gonna like be basically means that the steps in a formula or a topic?
You ever write CXC before? You write CXC, or you ever see a CXC question?
Yes, I did write CXC.
Yeah, it might be very well something like that.
Okay, all right,
Right?
thank you.
You'll see when you get test 1 and so what the thing will look like.
Okay, sir, thank
I'll
you.
show you all probably a previous test what it looks like. All right, I'll show you one. Don't worry yourself. You see, there's the next thing. You don't get afraid, right? Don't make, the minute you start get fearful of tests, you're defeating yourself, right? You got to develop confidence, right? And you have to develop confidence in the knowledge you have, right? And the ability to use it to solve problems. The minute you start getting fearful, oh gosh, I wonder what the test is going to be like. You're only going to panic and you're going to do badly, right? Don't let that go into your head. Anyway, good. Where am I? So we got up to here, and I was telling you I want you to do some reading. I sent some notes to you, and we're somewhere here now, right? There is this bit here. Let me just operations of numbers, right? And I think whoever put together this course outline have in mind the order the order of arithmetic operations. I think maybe that's what the person putting together, or persons, I don't know, have in mind. So what I'll do, I did this with another class yesterday. I'll chop out a piece of the video where I talked about the order of arithmetic operations, right? And we are going to get, a lot of, practice with this in time, right? So the order of arithmetic operations, I'm going to chop out that little piece and put it inside the this video here, right? Somewhere. I hope I remember how far. Yes, right? And you're gonna watch that, and you're gonna figure out what is the order that we do these arithmetic operations and so. And of course, you're gonna hear that funny story of how I thoroughly humiliated myself when I was a young teacher. But the lesson stayed with me for very long, right? Good. So we're kind of venturing in week 3, week 3 work, However, we can't cover everything here today, right? We're going to just touch on some of them. Let me ask, y'all want a 10 minutes break? You think you want a 10 minutes break?
Sir, we could get a 10 minutes break, but we need some practice on this LCM thingy.
Okay, you want some practice? Well, simple. What go to your Moodle page, right? Go to your Moodle page and try some of those. Wait, let me see if I can go back there. Let me stop sharing for a moment. Yeah. Yeah, go back to. Wait, let me show you what I'm talking about. One second. Yeah, these are the notes I sent to you, right? Good. So this guy actually, he used some different, he used a different approach, right? Yeah, you see he's using an alternative method here and so. So these are some examples he got. I know the time for this class, you can't get time to practice during the class. You got to practice in your own time, right? Right, friend? Whoever, I forgot who raised the objection. We can't practice in the class. You want practice in your own sweet time at home. You can get how much hours in a night you can do that, right? We can only cover an example or two and we got to move, right? So this is an exercise on exercise 2E here, you see here, right? Wait, let me see, not 2E. Look here, yeah. Find the HCF of 24, 60, 96, right? And let me just show you how, of course, if you use the method I showed you, right? You try it. If you have any trouble, you're not figuring it out, as I said, watch a YouTube video, or worse yet, you take this 24, 60, 96. Let me just show you. Oh gosh, what's happening here? Give me 1 second. And you type in here. Find the HCF of, what is it? HCF of 24, what else? What was the number?
60 and 96.
24, 60, and 96, right? Oh, sorry. Oh, they use a different method altogether. All right. They use a different method, but if you neglect, can you see what I'm having up here? Are you
Yes,
seeing what
sir.
the AI
Yes, sir,
spit
we are
out?
seeing.
Good. Yes. Good. So, all right. They did an extra step, a kind of different approach, right? So, they factorized 24. They got this 2 cubed times 3. You don't have to do this, but let's see what they did. 60, they break it up. You have 2 square by 3 by 5. Then you have 96 being all of this, which is 2 to the 5 by 3, right? And you're looking now for the highest common factor. So 2 square seem to be the factor of all three of these. 2 to the third, 2 square, and 2 to the fifth. 2 square is the highest common factor, right? Of all the 2's then. And then, okay, there is a 3 here, there's a 3 there, and there's a 3 there, right? By 3, but there's no 5 here, nor there's no 5 here. So your highest common factor is going to be 2 squared by 3, which is 12. I did not show you this, right? What's this? No. Can I? One
Sorry,
second.
mixing me up. This one here mixing me up with the
Yes.
square.
So avoid, all right, you're going to avoid this piece, right? Avoid this piece. And you're looking for common factors here. So 2, all right. There's a 2 there. There's a 2 there, right? So you get 2. Write it down. We have a 2 here. We got a 2 here. We got a 2 here. So 2 is common throughout. So we got another 2. There's a 2 here, but there are no more 2's there. And there's a 2 here. So 2 is not common to all 3, right? So you can't put no more 2's. Good. Let's see the 3's now. They got a 3 here. They got a 3 here. They got a 3 here. 3 is common throughout, so we get a 3. Then there's a 5 here. But there's no 5 anywhere else. Therefore, you're okay, right? You don't need to go further. So your highest common factor is going to be 2 by 2 by 3, which is 12, right? So you just got to look at the examples over and over. And let me tell you something. Don't, again, y'all are big people. You shouldn't want to be taught or spoon-fed. You got to learn to figure stuff out, right? You got to learn to figure stuff out, right? And that's how you develop your mind, right? Because I could do example from now to tomorrow morning. And when I give you one, you're going to holler, say, all right, do another example for me now. Or you're going to run to the AI, right? You got to understand what I'm saying. I showed you in the example. Look, you factorize the thing with its prime factors, right? Let me make it bigger. All right, let me make it bigger. Good. So as I mentioned before, I think I can't annotate. Yeah, good. So you take the number and you write it in the form of its prime factorization or a product of its prime factors. First, you got to say, do you know what I'm saying? Right? That's the question you got to answer. What am I talking about prime factorization? What am I talking about? You got to figure out that. If you don't know, you got to ask, what do you mean by that, sir? You got to write the number that, okay, all the prime factors that it has, when you multiply them, you get 24. So 2 by 2 by 2 by 3 will give you 24. If you try every single, yeah, I was showing you this example. Yeah, this here, right? Yeah. So, but just before we move off from this, I was telling somebody that first of all, they got to get clearly how to write any number in the whole wide world as a product of their prime factors, right? So that's the first thing you need to do. How do you do this? Forget this piece that the AI did. Forget this piece. You don't have to do that. So any number, that's what you want to practice. Okay, 100, how do you write 100 as a product of its prime factors? Well, think of the factors of 100, right? And what I do, even though I've been around maths for a long time, I break this number into 2 parts that I know, not necessarily prime. I know 100 is 10 by 10. And what I would do with this 10 now and say, okay, the smaller number now, This is 2 by 5, and that one is 2 by 5, right? So then you can arrange it 2 by 2 by 5 by 5, you know? So you have to practice this writing of any number as a product of its prime factors, which you see here. So that's what you got to do. Learn how to do that. And once you have done that now, so we do it for all of them. What we're looking for is common factors in all three of them, right? So we're looking, okay, 2, is there a 2 here? Yes, there is. Is there a 2 here? Okay, so it's common throughout. So we put down our 2. Good, let's see. There's a 2 here. Is there a 2 here? Yes, there's another 2 there. So for these 3 now, yes, again, you go with another 2, right? And then you look now, okay, there's a 2 here, there's a 2 here, but there's no other 2 here. So you can't put any more 2s, right? Same thing with the 3, there's a 3 here, there's a 3 here, but no 3 here. Oh yes, there is a 3, sorry, there is a 3. So there's a 3 there, there's a 3 here, and a 3 here. So you put on a 3. And there are no other common factors. There's a 5 here, but no 5 in this one, nor this one. And then you multiply and get your 24, right? So remember the steps, right? You write each number as a product of its prime factors. And after that, you look for common factors. And the common factors, you multiply them, and this here will be your HCF, right? Study the examples, right? I can talk and talk and talk and talk, unless now you take a pen, take a problem, try it, get it wrong, beat up yourself. Why did I get this thing wrong? Wait, let me go back to the example. What really is, you know, and you keep going over and over until you crack it, right? And then after you have cracked it once, don't stop there. Do a number of them, right? Do about 5, do about 10 of them until you fall into this thing where it becomes second nature to you, right? Same thing with the HCF. Let's take a HCF one. Not HCF. That was an HCF. Oh my! I'm supposed to erase all of this. I think if I stop sharing here and I go back and share.
So just one question. So basically, at all time it will begin with the number 2.
No. Why you say that? Not always. Let's take the number 15.
Sir, can you say what site you're using to solve this problem that you have on the other side?
Oh, this is Bing. This is Bing. You know, you use Edge. This is Bing. Can you see the corner here? Bing. It's usually bottom of your look at the bottom here. Bing is like a ribbon folded around. But there are endless sites out there. Gemini, there's Bing, there's Perplexity. What else they have? They have Copperwell. They have Copperwell. Right? Yeah. Okay, let's go
Yes.
to one with LCM. Okay, look here. Find the LCM of 24, 60, and 96, right? Let's ask the AI to do that. Find the LCM of 24, okay, 24, comma, 60, and 96. Okay. Let's see what they will do. Maybe they will use a different method, but let's see. Okay, they're doing a different thing too. So what they did is, okay, they write again each of the numbers as a product of their prime factors. So it's 2 cubed by 3 will give you the 24, 2 squared by 3 by 5. I notice they use the power, right? You don't have to, but that's their method. Remember I told you, everybody you ask, they will give you a different method, right? The method we use was this. So let me expand it out. Let me expand it out. Okay, that's it, all right? So we had two by 2 by 2 by 3, okay? And then this one will be 2 by 2 by 3 by 5. I didn't want to put in powers, and so, so that will confuse you, right? By 2, how many 2s? 5 of them. By 3, good. And remember I told you, okay, 2 is common here, all 3 of this, okay? But you're not putting it 3 times. You are only putting it once, right? Good. So 2 is common here again. You're seeing 2 in all, but you're not putting it 3 times. You're putting it just once. So there's a 2 here. There's a 2 here, but there's no 2 more here, right? So we're not putting 2 twice. We're putting another 2 there, right? Right? Good. So let's look now. There's a 3 here. Let me see. There's a 3 here. There's a 3 here, and there's a 3 here. But we're not putting it 3 times. We're using it once. Then what else? We got the 2 here. Wait, let me see. We represented that. We represented that. We represented these 2. We got to get 2 more, right? So before I go to the 3, I should let me just erase that. Let me not rush to the 3. We didn't take care of all the 2's, right? So there's a 2 here and there's a 2 there. So we go 2 by 2, right? And then we go to the 3. So there's a 3, there's a 3, there's a 3, but we're going to represent it 1 time. And then there's a 5. So we ensure we include all the factors, but the repeating ones, we don't repeat them, right? So even though there's a 2, 2, 2 here, we don't do it 3 times. We use 1, 2 to represent that. We got 3 2's here. We're not putting it 3 times. We're putting 1 time. There's a 2 here, there's a 2 here. So we represent it by this 2, not repeating it. There's another 2 here. Well, let me see. There's 2, yes. 1, 2, yeah. We got 2 2's. So that is why we get this other 2 here, right? And then there's a 3. And then there's a 5. So we have all of them represented. And I think when we multiply that, we're going to get it should be a big number. Let me see what it is. It's 418. You could always check, right? 418. 418. It should multiply to give you that. If you want to borrow their approach, right? Notice what they did. And just to show you, this is just another method, Let me go back to, well, this is what we were doing all the time. But look at what they did. So they took all the factorizations, right? 1 second. They took all the factorization. Like 24, 60, and 96. The highest power of 2 we got is 2 to the 5th power. That's one approach. You're taking the highest powers. 3, there was only 1 3. And 5, there was only 1 5. So you just take all of these and multiply them and you get your answer. That's their approach, right? But notice you had to take the 3 numbers and write them as a product of their prime factorization. You had to do it. So that's a must. Now they write everything in terms of powers now, right? I didn't include that because I didn't want to get into powers so early with you. And you take the highest power of each factor. 2 to the 5th power, they have it there. 3 to the 1 power and 5 to the 1 power, right? And I think this isn't a bad approach, right? In the textbook, there is even a third method, right? But this isn't a bad approach. You just use the highest power of each factor and you multiply. If you like this method, adopt it. Right? And this is simple Bing. They're not really a maths. I don't know if you understand AIs, right? They have what you call large language model, Bing and Gemini, and so those are what you call large language model, meaning they try to answer everything to people. If you want to ask them what causes headache, they tell you. You know, what is a good cure for cancer, they tell you. They try to answer everything. However, there are what you call small language models that are made sometimes just for mathematics, right? And I think Gemini had something called Math Solver, right? Math Solver, right? And that's a smaller language model inside of Gemini that does only mathematics, nothing more, right? They got people who do AIs for only one thing, you know. I have a student who works with there's a student who works with AI company in America, and that AI, this is what it does. It helps dentists. So what happens when you go and you do a scan of your mouth? You know, you do this. There's this scan you do of your mouth. There's this machine that kind of do an X-ray of all your jaw and teeth and so. Now, doctors might have difficulty. They might, if you're really, really experienced, right? You could very well read the thing accurately. However, to get some help, you know, to make sure that you don't make a mistake, this AI, you upload this image to them, and this AI will actually interpret the results for you. Anybody ever did a what you call an ECG or an AEKG, echocardiogram?
Yes.
Yeah. You ever read the thing? You ever watch it right to the side? The thing has an interpretation there, right? So the computer does the interpretation, right? Same thing if you do an ultrasound, the thing will tell you that, or if you check your kidneys, it will tell you that it has stones this size and that size, and you know, it will tell you how much stone they in you or how what size it detects. The computer program does it. Well, an AI is simply okay, that computer program that is available to the whole world. So if you have a hospital in Georgetown named Morrissey or what, right? That computer is only going to do it for Morrissey, but this AI does it for the whole world. You have to pay for that AI though, right? You probably pay $100 a month or you know, depend on how much. And that AI will help you as a doctor, as a dentist, right? Give you recommendations, tell you procedures that you can do to correct this thing that you watch. You see this money? A root canal can be done there to save that teeth. You know, it will tell you specific things, and you know, will tell the person, watch, this teeth you can save it. You can do a root canal. You get any money for do it? Yeah, let me do it. Next one, I say, look, you know what? This teeth we can't save it. Does he have the bone structure or the bone mass to do an implant? The AI will tell you what that yes, do it. You know, you can do it. He has the bone mass, right? So yeah, they have AIs for everything, man. Right? I use a very famous one named Symbolab. Y'all ever heard of that? Symbolab. It's one of the best out there. It's built just for mathematics. Symbolab. Right? But you have to be a little bit of math savvy, you know, to enter what you want to enter into it. And so because when you go on it, you will say, man, this is what source is the best. You know, me and understand one thing we're going on here because it takes some, you know, you gotta learn it. You gotta learn the syntax of mathematics, you know, the grammar of mathematics. How do you write, enter things into into the AI, you know? So yeah, AI is there, and everybody hear about AI, but using AI is a different story, right? How to ask it to do stuff. You gotta know how to ask. right? When you're dealing with an AI, don't ask it to please do stuff and thank it and so on, right? It's a machine. Don't, when you say please and thank you, the AI has to process those words, right? And it's costing Google and these other places millions of dollars because it has to analyze, well, this word please, what does the prompter want me to do with this word? Why did he say please? Right? You see how I said it? Look at what I said. I said what? What did I say? Find the LCM of 24, 60, and 96. It's a command. You tell it what to do. You are the boss. Don't tell it thanks. We're telling it thanks for you're making the model work. The thing has to work harder, right? So don't tell it thanks and tell it please and all of that, right? It's not a human being that it understands that, right? So you have to know to tell it stuff, keywords. Okay, good. Yeah. So my problem now was what? Yeah. So this is the exercise I was pointing you to. Right? Of course, I could give you the answer for each one of these. This thing comes from, you know, that Ford Farm textbook that you all used to use at CXE. That's where this comes from, right? Of course, if you
I get
want to
one.
know, yeah, if you get one, yes, you can check it out, right? If you want to know the answer to you want this one. What is the least sum of money that can be made up of an exact number of 10-cent pieces or 25-cent pieces? You know this is an LCM problem. What's the LCM of 25 and 10, right? Good. You work it out and you're not certain, but I want to tell you this. If you work a maths problem and you're not certain, you don't really know what you did, right? If you know what you're doing, you will know when you are right and you will know when you are wrong, right? I keep telling students that you mustn't depend on the answer the back. If you follow the example and you know what you're doing, you understand what the man tell you in the class, or the example in the book, or the example YouTube explain, if you understand it, when you do a problem, you know what check answer. I don't know if it's this class I was talking about and you were talking with, you know, students, when they do an exam, you must know your grade. You can't wait. You don't wait for grade. You should know your grade. So you come out, you know if you ace the exam. If you do stupidness, you know you do stupidness. Right? You will know. You're supposed to know. If you don't know, well, you are just floundering around all the time. Right? But anyway, let's say you need some kind of confirmation, some assurance that you're going right. You could just type the thing into an AI and let it confirm that your answer is right. Right? Yeah. So I think our time is creeping up on us. I'm sorry about that conversation with my boss because he been to some meeting and get some licks, and he want to transfer some licks to me. So he called me. No, it's nighttime. I know he fretting and quarreling and arguing about. So I don't want us to. I don't think. Let me see. Let me stop sharing for a moment. I'm going back to the course outline. Yeah, so we kind of end up here. We didn't get past this part here. So, all right, what I'll do, I said I'll cut a piece of the video I did with the other class on the order of arithmetic operations. In that video, we didn't do any example as such. But when we meet back, we're going to do a few examples, right? And then we'll get into some real algebra, you know, substitution, removing brackets, addition, subtraction, multiplication, and division, and so on, right? So when we meet again, that's when next next Tuesday, right? And that has to do with well, they refer to it as mathematical operations, right? Now what we're talking about is the order of mathematical operations, right? I know my writing isn't of the best, right? And that got to do with, well, you have a set of operations to perform and some real numbers. Let's just throw one up, Maybe you have 5 minus 2 bracket 3 plus 1 square divided by, let's say 2, you have a complex thing like this, and you're told to evaluate something like this. Evaluate that. There's an order in which we do things, right? One might be tempted to look at this and say, let's start from here. 5 minus 2 is 3. Okay, all right. Now we put this in here. What do we do next, right? Maybe we multiply the 3 into that, no? And get 9 plus 3 squared divided by 2. Is that what we do? Right? No, all of this is garbage. No. There are rules as to which operation you do and the order in which they're done, right? And that's what we're referring to here. The order of arithmetic operations, right? So I'm going to go with that just to give you an overview, and then we'll look at some examples. And there's a nice, a little memory aid, right? That you can use to remember how it's done. Right? I don't know if you remember this from high school. Anybody know what the B means?
Bracket.
Okay, you work out what's in the bracket first, right?
Yes, sir. Yes, sir.
Work out operations in the bracket first, right? Okay. What is O means now?
Of.
What is this of now? What's that? Anybody can elaborate a little more? Of?
Multiply.
But I think this M is multiplying. Of the O can be multiplied and the M will be multiplied. Can't get it 2 ways, right? I think the O refers to powers of, right? So work out powers of numbers, right? So after you have done brackets, you can now work out powers of numbers, right? Then division, then multiplication, right? I'll tell you a little about these two, right? They can be done in the order they appear, right? There's an E here, they appear. So even though they say you have to do division before multiplication, you can very well do multiplication before division if that's the order they appear. I'll illustrate just now with examples, right? And I'll tell you a funny story. What does this A mean? Anybody knows?
Pardon me, sir?
What does
Addition, sir? Oh, the
I
A is addition.
Okay, I think you need to qualify that better. Add positive numbers, right? At positive numbers, not just add. I'll show you again why I'm saying this. And lastly, subtract, right? However, these two operations, like division and multiplication, can be done in the order in which they appear, right? So they can be done in the order they appear, right? Good. So we'll deal with some examples with brackets and powers of and so just now. I want to deal with this division and multiplication thing, right? And why I'm saying that even though division, say, this thing is saying do division for us, you can do them in the order in which they appear. And I'll tell you a story quickly. When I was a young teacher, and I'm talking about nearly 30 years ago. So, you're young, you're full of energy, you think you know it all, because that's how young people operate, you think you know it all, and nobody can tell you not, you know it. You've been to university and blah, 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 Good. So I remember I went to a seminar, a famous seminar, and we talked about BODMAS, and we had this division, then the multiplication, right? And I was telling them, you have to do division first. You have to. And then you do multiplication. So there's a famous man. He's very popular in Guyana. And those of you, if you're living in environs of Georgetown, you'll hear of Mohandat Gulsaran. Anybody know that name? Mohandat Gulsaran?
No, sir.
Okay, you don't know that name. All right, good. So I remember he said, okay, all right, if you're fighting up that you must do division first, right? So he put his problem up on the board. 10 multiplied by 2 divided by 5. So I went out and I say, man, and mind you, this was a seminar of all the math teachers in Region 6, right? And I was teaching at multilateral school at the time. And I remember, but people think that, well, the best guy will be at multilateral, and multi sent their best to this seminar. So I went out and I'm arguing that you have to do 2 divided by 5 first because that's what the rule says, right? So I did it, and 10 multiplied by 2 over 5, right? I wrote it like that, and 5 multiplied by 1 and by 2, you get the answer 4, right? So I did that, and the guy said, all right, okay, all right, good. So the man says, do it in the order in which it appears. So if you do it in the order in which it appears, you get 10 multiplied by 2, you get 20 divided by 5 equal to 4. You see what happened there? And guess what? When I did that, the entire audience, which is about nearly, about 50 people, they start to cheer because I think I learned my lesson. I never forgot, right? I was thoroughly embarrassed. I wish that the floor had a hole and I could have fallen through. But those lessons I'll never forget, right? I like to tell the story, even though it embarrasses me, but I learned my lesson. So yeah, look at this. Insisting on doing division first makes you, you produce a fraction that is horrible and, that sort of thing. But you could have very well do the thing in the order in which it appears. Look here, very, very simple, right? Good. Let me go to our next one. I don't have a story to go with that one. So look at this one. And I'll tell you, even at the university level, a lot of my students will have this wrong. So I'll do this, okay? 10 minus 2 plus 3, right? And all we said just now, you have to do addition first and then subtraction, right? That's the order. So if you were to do that, what will you do? What will you add and so forth?
So I would minus the 10 from the 2. Then I would add 8 plus 3.
You minus the 10 from the 2? How you do it? The 10 in front here, you know? You mean the
Sir,
minus the 2 from the
first,
10?
Yes, sir.
No, let's go with this rule. The rule says you have to add force. What will you add force? That's what the rule says,
Sir,
right?
sir, could you add the negative 2 plus?
Or you're adding negative 2 and the 3. Okay. But this is a subtraction sign. This is not a negative sign. What will you add force?
sir, first, I think I would have bracketed off first to make it easier for me.
Bracket what
So
out?
I would have put 2 and 3 in a bracket. And I
So
would
you,
have add 2 and 3 first and then minus it by the 10.
oh, all right, good. So you are seeing something here now, right? Remember I said this A doesn't mean adding force. It means adding the positive numbers force, right? And when you look here, somebody did say it, right? But I'm deliberately wanting to mislead the class, right? Because you know when you know that you have adhered to the rules, you got to hold your ground, right? So when I doubted that, everybody caved and gone all other directions. So somebody said, okay, you could add the negative 2 and the 3. But the rule says add positive numbers first. So the 2 positive numbers are the 10 and the 3, right? 10 and the 3. So the 10 and 3 will give you 13, and then you subtract the 2 and you get 11, right? So if you add positive numbers first, the 10 and the 3 gives you the 13, and then you subtract the 2, right? Alternatively, as I said, you can do it in the order in which it appears. So you just go 10 minus 2 is 9. 9 plus 3, 11. You see? So if you're adding, you have to add the positive numbers first. And then you subtract. Or you do it in the order in which it appears. Right? However, somebody did say something that makes sense. And I want to... what's going on here? My whiteboard is moving. What's going on? What is doing that? Every time I do that, what's happening there? I might have to refresh this whiteboard because it's behaving crazy. All right, let me go back to it. Let me do another whiteboard. Can you see a new whiteboard now?
Yes, sir.
Good. So somebody said this. 10 minus 2 plus 3, right? And they said to add negative 2 and 3, which is not a bad idea if you really know what you're doing, right? So if you do that, negative 2, you could actually treat the subtraction sign like it's negative, right? So you're actually saying, okay, this is like 10 plus negative 2 plus 3. So you can do this piece, right? And you get what? You will get no, you wouldn't get the right answer there. No, you see that? Look at that. If you do that, you will get what? 10, what's this? Plus 1. No, you get the right answer. Yeah, you'll get the right answer, right? So yes, you can do that, right? you can treat this as a plus sign, right? And put this subtraction sign as a negative, right? So these two, when you add them now, you get the 1, and you add it to the 10, you get 11. So that's an alternative, but you really have to know your negative and positives, which we'll touch on a little later, right? So that person wasn't wrong, right? It's a little bit of deeper thinking, which is very good, right? But I wanted to stick with the rule, add positive numbers first, right? And then subtract. So this person went contrary and said, look, no, I'm not adding positive numbers first, right? I'm changing the problem to a totally addition problem because what? Addition, addition, right? This subtraction sign, they convert it to a negative sign, which nothing is wrong with, right? I hope I'm not confusing the rest, right? I will tend to tell anybody to avoid this if you're a beginner, right? If you're a beginner, don't tread down that line, right? Don't tread down that line. Good. So with that now, we can actually do any problem that involves the order of arithmetic operation, right? So remember the little bit of memory aid, board mass, right? Board mass, right? It's more of a, what do you call it? An acronym, a mnemonic. A mnemonic is a memory aid, right? So you work out what the operations that are in the bracket, then powers of, then you do division, then multiplication, but these two can be done in the order they appear. You add positive numbers first, then you subtract, or you can do them in the order they appear, right? Good. So that's that bit there. We're going to do some examples and so later on. Don't worry yourself, right? This is just to capture everything. Good. So I wonder why this thing isn't moving. Is it malfunctioning? It's not moving the why am I getting that? Oh gosh. Let me close whiteboard. Just give me a second, right? I'll stop sharing for a moment. Whiteboard is misbehaving, man. Let me open back whiteboard and see what happens. You usually take the hand and move the whiteboard. I don't know why it's not moving now. Give me a second, right? Yeah.